Yo, what's up guys? Today we'll be talking about sinusoids and what they are. So if you like this content, consider subscribing, but now let's get into the video. So, let's talk about sinusoidal graphs and what do they look like. Sinusoidal graphs are functions that look like a wave, and they might do something like that, okay? Something like that, like a wave, okay? How you can create these sinusoidal waves are by using sine and cosine, okay? Just write those up there. So let's try to graph y is equal to sine of x. Okay, well, what would that look like? If I get out my graph right here, so how can we go about this? Well, what we can do is how you can measure sine is in degrees or in radians, right? So let's have our x value be radians, okay? So x is radians, okay? And so we can reference our unit circle, okay? And so when radians are equal to 0, so 0 radians, so 0 degree angle, where is sine? Well, remember, sine is the y coordinate. So right now sine is at 0. So we know at 0 it intersects the origin, okay? Now let's go up just 90 degree angle, okay? So if I here, let's mark out our radians. Okay, so now that I put some labels on, let's figure this out, okay? Well, if it's at a 90 degree angle or pi over 2 radians, where is it? Well, if it's our unit circle, we know the radius is 1, right? And if it's completely vertical, then we know that our sine is equal to 1, okay? And now let's go to pi radians. Where is it? It's at 0, okay? But now, where is, let's go to 270 degrees, or 3 pi divided by 4. Where is that? Well, it's the radius is 1, but it's going negative, so it's going to be negative 1, okay? And then we can go to 2 pi. At 2 pi, that's a full circle, so it's back at 0 again, okay? And now let's just go negative. So if I were to make a new wonderful circle right here, and we're at 0, we go negative, so it's going to be that way, right? So let's go to negative pi over 2 radians. Well, we know that's completely vertical, and the radius is 1, right? But remember, it's going negative, so it's going to be at negative 1 when it's at pi over 2 radians. Okay, well now let's go to pi, negative pi, okay? Which when you go to negative pi, sine is at 0, right? Because it's flat. The y value is at 0, okay? So at negative pi radians, we're at 0. And now we can go to negative 3 pi over 4 radians, which is, remember, it's completely vertical. The radius is 1, but this time it's positive, right? Because it's going up. So positive, and at 2 pi it makes a full circle again, so it's at 0, so about there. So if I were to get a good drawing here, we can do that. Kind of missed it there, but it's going to look something like that. I'm not too good at drawing with this. That's what y is equal to sine of x would look like. Now that I've fixed this up a little bit, let's talk about y is equal to cosine of x. That was bad, cosine. Okay, well, how do we do this? Well, if we look at our unit circle, let's just start at 0 radians. At 0 radians, remember, cosine is the x value. And remember, if it's completely horizontal and the radius is 1, then we know that at 0, it's going to start at 1. And now, okay, well, let's go. Here, let me just make this circle. Okay. And now let's go to pi over 2 radians. Well, remember last time for our sine it was 1, right, because it's completely vertical. But now with cosine it's at 0, right, because there's the length of this is 0, right, because it's completely vertical. So we're going to go right here, okay? Now let's go to pi radians, and again it's at 1, right, but it's going negative, right? It's going to the left. So at pi radians, it's going to be negative 1, okay? And now let's go to 3 pi over 4, which is down here, And again, in this case it's vertical, so it's going to be at 0. And then at 2 pi, it's back to normal. It's back to where it was. So it's up here. And of course, we can do this backwards. So pi is 0, and pi is -1, and then 0, and then 1. And so the blue is what the graph of y is equal to cosine of x would look like. Okay, so for those of you who may be aware of some of the trigonometric functions, you guys may be aware of tangent, written as tan, okay? Well, what is tangent actually? Well, we know that with our unit circle, we know that, in the x value is cosine and the y value is sine. But where does tangent go? There's not a third dimension to the circle. So, actually, tangent of our theta is equal to the sine of theta, or that angle, divided by the cosine of that angle. Okay, so let's try to graph tangent. Let's start graphing this, okay? Well, let's say that we have, okay, well, let's just start at 0, okay? Where would tangent be at 0? Well, if tangent is sine divided by cosine, well, at this point, it's going to be 1, 0. And so that means cosine is 1 and sine is 0, so 0 divided by 1 is 0, okay? Cool. Now, let's look at, how about 45 degrees, okay? So somewhere in between here, at pi divided by 4, that at this point, it's the square root of 2 divided by 2, and the square root of 2 divided by 2. So, when we square root of 2 divided by 2, divided by the square root of 2 divided by 2, is 1. So, if I were to just, how about I write 1 right here, so we know it's right, that point's right here, okay? Now I can make a -1 down here. And so that means the same thing for negative. So if I were to write this down here like that, it would be -1, right? Because it would be -1 because cosine stays positive, but sine becomes negative, okay? Well, what happens as we slowly increase the slope of these lines? Well, what do we know? Well, at these points, this point and this point, it's 0, -1, and 0, 1. So cosine is 0, and sine is either 1 or -1, okay? And so what does that mean? Well, let's do 1 divided by 0. Well, you can't, okay? But what we could see is that if we do, okay, well, 1 divided by 1 is 1. 1 divided by 0.5 is 2. 1 divided by 0.1 is 10. So we find that as the denominator gets smaller, it approaches infinity, right? Or at least it gets larger and larger and larger. So at 0, which is technically undefined, but we can say that as it approaches 0, it approaches infinity. And knowing the properties of some exponential functions, the asymptote is going to be at y is equal to, at pi divided by 2, and at negative pi divided by 2, because we have, when it's -1, it's going to be -1 divided by 0, so it approaches negative infinity. So we can write that like that, and the asymptote at pi over 2, okay? Now, let's say, okay, well, there's still more. The graph doesn't just stop there because you can keep rotating, okay? Well, past this point, again, it's still very negative, right? Because it starts to, this slope is negative because cosine is negative, but sine is still positive, right? So when you have one negative and a positive, it's going to be a negative, right? But it still has to have very small value. So if we have 1 divided by, I don't know, -0.001, it's going to be -1000, right? It's getting away from negative infinity. So if I were to complete this down here, and we can find that it starts to come up here, right? Because it's going away from negative infinity. Well, at pi, we know it's going to be 0, right? Because at this point, it's just 0, or sorry, negative 1, 0. And 0 divided by negative 1 is just 0. And in between this point, it's going to be, remember, it's the square root of 2 over 2 and the square root of 2 over 2. But because it's cosine, there's going to be a negative square root over 2. So when you divide those, you get negative 1. So it's right there, which, points about there, okay? And then if we were to go past it, okay, to, how about here, right? Again, it's going to be both negative, so it's going to be a 1. So if we complete the graph, it's going to kind of go like this. But then what next? Well, as it goes down here, it approaches positive infinity, okay? And you're like, okay, well, why is it positive infinity? Well, that is the third quadrant. And in the third quadrant, both the x-coordinate and the y-coordinate are negative. So it's going to be, it's going to approach negative 1 divided by negative 0, which that doesn't really make sense, but it's really it's approaching negative 1 and it's approaching 0, but from negative. So it's going to be, it might be negative 0.01. In that case, it would be positive 1000. So it approaches, well, I'm going to make another mark here, 3 pi over 4, okay? So I'm going to make an asymptote here. So as it approaches 3 pi over 4, it also approaches infinity, okay? And what you would notice is that you can do it. This occurs in both directions. So if we were to go this way, it's going to start to, might look something like this, and we can keep going this way, right? And it might look something like that. So this continues on forever. So tangent's a very weird graph, but it's very important to know. Hey guys, so thanks for watching. Today we covered what the graphs of different trig functions look like, and next video we'll be talking about the different properties of sinusoidal waves. Peace.